Okay, SpaceX SN10 launched, landed, video analysis. So that's what I'm going to do. So I want to step through the process of how I would, and I actually want to make a model, a Python model of this rocket as it lands. And I'm going to step you through the process. We're going to do everything. Okay, so first, let me switch over here to, let's see, where did I put it? Right here? No. Let's see, right here. Yeah, so this is the video I'm going to use. This is one I found on Twitter, and I really like this one because let's see, if you can see the whole motion, right? The camera moves on around a little bit, but we can handle that. Now, there's another much more awesome view. Here's the one from SpaceX, and let's just skip through this a little bit. This even looks fake. I actually thought this might be fake. It's real, and I'm like, that's just crazy. That's a crazy shot right there. And then you could analyze this one too. That's a really good shot right there, but you couldn't get all the turning motion and stuff like that. So I'm going to use this one. If you want to do the other one, that's great too. And my chair is squeaky, I apologize. So what do we do? So I have the video. So I'm going back over here. This is Tracker Video Analysis. It's a free Java program. It's pretty awesome. And there's a couple things that we need to do to get data from the rocket in each frame. And in particular, model it. I want to know, like, not just where it is, but which way it's oriented. So I'm going to essentially mark 2 points on this. Let's see if we zoom in a little bit. So the front and the back. But the very first thing to do is to set a scale and set the axis. So if I go down here, you'll notice that as I move through the frame, looking at these buildings or whatever they're on the back, they tend to move around. Okay, so let's go ahead and put an axis in there, and let's try to mark it right on that. Okay, and then I can kind of see that I want to keep it right there. I can get the angle with respect to the horizon, to the water level and stuff, so that's going to be great. The next thing I need to do is go up here, and I'm going to set the scale. Now this video is pretty far away, so if you're looking at an object up here versus down there, it's not that much further away. So I'm going to use the actual size of the rocket itself as the scale. So if you look up, let me zoom in a little bit more, 200%. If you look up the size of this rocket, it says 50 meters. I'm pretty sure that's right. So I'm going to go to here, new calibration stick. Now I'm going to shift click on the front of that, and then on the back, and then it says 39. It doesn't know how long that is. I'm going to type in 50. Now I've set the scale to 50 meters. I'm going to move it off to the side. Now the next thing I want to do is go to the coordinate system, and I do not want the origin fixed. I do not want the angle fixed. I'm going to assume that the scale is fixed, even though it may or may not be. Okay, so now the next step is to get this exactly where I want it, see where it is, and now I'm just going to go to the next frame, and the background moves, so I need to move my coordinate system, so I'm just going to drag it and put it right there, and then skip to the next frame, and then drag it. Yes, this is tedious. And then if you need to rotate the scale, you can just, if it turns, and just keep doing that. This is going to take forever. So have you seen those baking shows where they set something up and then they pull another one out of the oven? Yeah, I'm going to do that because this is going to take forever. So I'm showing you how you do it though. So you'd go through the whole range of motion and make sure the coordinate system's in the right spot. After that, you go to create point mass, and then I'm going to scroll up here to the rocket, and I can give this a name. Let's say this is the top. And what I'm going to do is just click on the top of the rocket. I'm going to hold down the shift key and click on that. And it'll skip forward a frame, and then I click on it again. And then it'll skip forward a frame, and I'll click on it again. And then it'll skip. You get how this happens, right? Okay. And you can see it's recording the data. I'm blocking the video over there. I'm going to turn off the video in just a second. There is a thing up here you can try, auto tracker. And so auto tracker, you define some region of space and then it tries to figure out where the next thing is later. And it does a pretty good job. It doesn't always work. And so sometimes if it's something I really want, I'll just, I'll just do it manually and suck it up. So that's what you need to do. Number one, move the coordinate system in each frame. Number two, number one, set the scale. Number two, move the coordinate system. Number three, mark the location of the top in every frame. Number three, what number one? Next, mark the bottom in every location. And in fact, later on, I did something else. I marked this. I marked the end of the thrust because just in case I want to kind of like analyze, you see how the rocket here is in this orientation, but the thrust is angled. I recorded that too. Okay, so I did all that. Check it out. Let's see, view, right here. Okay, let's do this. This is the first thing I like to do. I'm going to pull this up. That's even more. And then go back. This is the world view. So this view down here shows the corrected frame so that it doesn't move the coordinate system. So if I correctly put the coordinate system in the right spot, then this should look okay. And it's running slow because but there you can see it will just move this video around to give you the thing. And you can save this as a GIF, which I love to do. In this case, the frame didn't move too much, but there you go. And so there's my points going around. Let's just stop that. Okay, let's turn on this video. So over here, I have the data. I have the graph. This is the thrust as a function of time. Let's change this to the top. And then you can see this is the position of the top as a function of time. In the X direction, I can change that to the Y direction. There's the Y direction. That looks pretty good. Everything's fairly smooth. Now, what I could, look at this and find the acceleration by fitting a quadratic here. I could find the velocity. I could do a whole bunch of stuff. But I'm just going to model it, and you could do something else with that later. So down here, I actually have the time and the position data for the bottom. And so if I copy this and paste it into Excel, now I want to use this actual data in Python. So I'm not gonna model it. I'm just gonna repeat it. I'm gonna put these values into my sheet, my program, and then just model the motion. Okay, so it'll be kind of fun. Here's what I'm going to do. So I copy the bottom, the top, and then I have the thrust. So over here in Google Sheets, I have all my data. This is I just copied and pasted it from what's that program called? Tracker. So I have the time. I have the time. Oh, what? That's weird. This one has an extra data point. See, that's a good thing I did that. Here's the time for the top. Here's the time for the bottom. And you'll notice that this one is at 0 and that one's not. So let's just delete this stuff. Delete and shift up. There. Now they have the same time. So now I don't actually need that time column, but they're all the same. So I have the top, the X of the top, the Y of the top, the X of the bottom, the Y of the bottom. Okay, now we need to get that into GlowScript, and here is the tricky part. I guess it's not super tricky, but yeah, it's kind of tricky. It's a trick. So the time, actually, I don't need to copy the time data, because if you look right here, if I say this is equal to, actually, let's do this one. Let's do this next cell is equal to this one minus this one. I get 0.0146. So they're all the same. So if I start at a time of 0.0146 and then I have a time step of 0.041666 or whatever, then I can just I can create all these times. I don't need to copy them. Okay. So let's go over to GlowScript, which I have in a different browser because that's how I like to roll. And I want to go ahead and get all this data. So let's call this xtop. Right? Let's just get that data in here. And I'm going to write it as a list. And I'll include a video down below about how to do lists. Now I'm going to go back over to my other browser because, xtop. I'm going to copy this Whole column. There's a lot of data. And this is how I do this in GlowScript-VPython. If you use normal Python, you could have this as a file and you could read the file. That's not a big deal. Okay, but I'm using GlowScript online and it doesn't do that. I could just do this, paste it in there, but it's missing all the commas, right? And it looks weird, so I don't do that. Instead, I'm going to go to a text editor. Here's a text editor, and I'm going to paste this. Now I'm going to say Control F, find, and I'm going to find, actually, I don't want this yet. I want to highlight. I want to get rid of the return, so I'm just going to highlight that area and say copy that. Now I'm going to find that, Control V, and paste that in there, and replace that with a comma, and replace all. Replace all. It didn't replace all. Let's see. Control Z. Okay, maybe I didn't copy that just right. Copy. Control C. Find. Delete. Find. Replace all. Replace all. There we go. Okay. So now we have a giant mess. And that's fine. Now I'm just going to copy this. This is a terrible thing to do. I mean, you should never do this, but I'm doing it. Copy that. And it's just one long line, and I'm going to paste it into here. There. Okay. Now, just to show you that this is indeed there, let's say for... no, let's get some more data in there. Now we're going to do this for y top. I'm going to do the same thing, equals... And yes, this is stupid. I agree. Don't worry. So I'm going to go up here. It's barbaric. You could say, this is barbaric. You should never do this. You're a barbarian. Okay, delete that. Paste. Alt F, find, replace all. Done. See? And then I'm going to copy. And I'm going to go over here to Python and paste. And yes, I probably should have done this already, but I didn't. Now I need... X bottom, and then go back over to here, X bottom, scroll down. I just wanted you to realize and appreciate how long I spent on that video clicking each frame just for you. Okay, I did it for me, but so delete this, paste that, find, replace all. See, it's not hard. And then go over here, X bottom, and then Y bottom. And one more. Oh no, I have thrust too. Yeah, let's just go ahead and do the thrust too. So, which I put in a different sheet because I didn't collect all the data for thrust because it wasn't always on, and then I got bored. So Control C, go back over here, delete, Control V, Control F, replace all. That one looks shorter. Did I not get all the data? I didn't. Haha. See? Shift click. Did that get it all? Control C. Oops. I shift clicked it. No, see, I didn't. Okay, so let's just do this the right way. I keep messing up. Go back down to the beginning, click that one, go all the way to the top. Shift click Control C. Okay, now go over here. Control V, Alt F, replace all. That looks better. Shift Control C over here. Control V. Okay, now let's get X thrust. Now I did put this, let's put over here T thrust, because I started this later. T thrust. That's just thrust. T thrust 1. This is the beginning thrust time. So if I go over here where I put this in a different sheet, it's at 1.51466. Let's just copy that. I mean, why memorize? We can just copy. And then over here, I'm going to say, copy the x values. It is long. Even that one's long. I hope you're not bored. Okay, Control F, replace all, copy, Control C, go in here. Now do the same thing for the y value, y thrust, and copy that data. I do need this final time. Let's get that. Control C, T thrust 2, and go back over here, copy, Shift, Control C, almost got it, almost got it. Alt F, replace all. Okay, looks like we're doing well. Okay, and did I get dt? Let's go. T equals one more thing. T, let's go back over to here to sheet 2. T is this, which we could start at t equals 0, doesn't matter, but I don't really care. And then dt equals that too. Okay, we are ready to roll. Let's go ahead and, I did have the ground at y equals 0, so let's make the ground. And let's make these two objects, and let's save this. SpaceX SN10 landing. I really don't know how well this is going to work. Okay, so ground equals box. And I'm thinking this kind of has to be kind of huge. So let's say it has a position of vector 0, 0, 0. Oops. And a size of, I want it to be fairly thick. Let's say the x value is going to be equal to, I'm looking at -40. I'm looking at the x values 8. So let's say the size is 100. It's 100 by 10 by 100. And let's make it green. And now let's run that. So there's my ground. It seems kind of thick, and not big enough, but that's fine. Let's just proceed. Okay, now we want to make the, I'm trying to think here. So I want to make a cylinder. So let me switch to the paper over here so we can talk this out. Okay. So here is my, I have the ground. And then I want to represent the rocket as a cylinder, because that's an object in Python, like that. So in Python, we need two things. We need the position of the cylinder, which is going to be the bottom. So POS is going to be the vector x bottom, y bottom, 0. And let's just assume it's in a flat plane, which it actually might not be. Okay. Now, the other thing I need is the axis. And this is the vector from the position to the end. So let's call that, let's just call that the vector A. So this is A. And look, I actually have, here's my origin. I actually have data for R bottom and R top, right? Because that's my X and my Y and Z. So if I say A is just going to be equal to the final position, R top, minus R bottom. And then R top is going to be equal to X top, Y top, 0. Okay, so I think I can do that. So let's switch back over here and do this. Oops, sorry, I hit that. Switch to computer. So now the other thing I need to do is to go, oh, I do need to build the times. Let's go ahead and build the times. Let's just say, let me just check here. Okay. Print length of xtop. And let's print the length of, let's just check to make sure they're all the same. Print length of y bottom. And let's run that. So they're the same length. They're 343, just to check. Okay. Now let's go to for I in, let's say this. T is, ooh, T0, let's call that. T is a list. It's an empty list. And I'm going to say for I in range length xtop. So now it's going to have, if I did this, it'd print out I 0, 1, 2, 3, 4, and 5, and so forth like that. Then all I want to do is say T equals T plus if I do I, that's fine. Let's do I times dt. So I is going to be 0, then 1, then 2, then 3, and 4. And then so this should print out, this should make a list of times. And then this is print, this is just a check. Print len of t. And let's print print t negative 1. This should print out the last element in the time, just so we know what that should be. 18.76. Is that right? No, sheet 2. 18.76. Is that the last time? Well, it actually may be a little bit differently because I started at t equals 0. Yeah. Okay, that looks good. Good enough. Good enough. Excellent. Excellent. So we have our times now. Okay. Now let's do this. Let's say, let's go ahead and make our rocket. So let's say SN10 equals cylinder. Position equals the bottom. So it's going to be vector. And then I'm going to say x bottom 0. That's the first position. Y bottom 0, 0. And let's say RA for the axis vector. It's going to be vector of the top, which is going to be x top, y top 0 minus vector. Oh, I didn't put these. These are lists, so I have to put a 0. I have to put a 0 there. Minus vector x bottom 0, y bottom 0. If this works without like a whole bunch of errors, I'm going to be kind of impressed. But so there's my position of my cylinder, and then the axis is going to be equal to RA. The radius, I don't know, I forgot to look up the radius of the thing. If it, let's say it's 10. And let's do, should we leave a trail? Yeah, let's do that. So let's say make trail equals true. I'm going to leave it as gray because, you know, that's what it looks like. So let's see if this works. Okay. Okay, my ground's not very big. That's fine. Let's just make the ground bigger just so it looks cooler. So we can fix that. See, it's art. This is not just, this is art. Let's say it has a width of 500. Okay, I'm good. I'm happy. I'm happy with that. It's not very wide. That's fine. We don't need the whole ground. Okay. We're working right along here. Just double check everything. Okay, that looks good. Okay. I said okay like 5,000 times so far. So I want to make a loop through time. So let's say for I in range len of t. So now I is going to be an index. And I have to make it an index because I don't want to do I for t in t temporary in temp, because at time it would just give me all the times, but I need that index so I can refer to the same position in the other lists. So the first thing I'm going to do is, let's say, a rate. Let's see, this is, let's just call this, this tells me how fast to do these things. Let's just put this at, let's see, is it, what's 1 divided by temp rate? I can't do that in my head. 1 divided by dt, let's just put that. So temp rate, there. That way I didn't have to calculate it. So rate tells the Python not to do more than that many calculations per second. Now what I need to do is to, let's go ahead and calculate R top, R bottom, and that's what we need. So R top is going to be equal to the vector x top I, that's the ith element in x top, y top I, 0. Not O, I just made him O and did it again. O, 0. And then R bottom, it's going to be the same thing, but x vector x bottom I, y bottom I. And I haven't done the thrush yet. We can go back and add that later, 0. Now I can make my, I can update the position of my cylinder. SN10.POS is just going to be equal to R bottom. SN10.axis is going to be equal to, okay, now it's possible that my positions change because of the way I mark them. So I don't want the thing to change the length. So let's just say, let's go up here and say L equals 50. L equals 50. That's the length. Oops. L equals 50. That's the length of my rocket. So the axis is going to be L times the unit vector R top minus R bottom. So that way I know that the axis of my spacecraft is always going to be 50 meters. So I've updated the position. I've updated the axis. I think that's it. I don't know. I feel like I'm missing something, but I think that's it. So let's save that. And then let's run this. What the heck? I want to zoom in a little bit. Okay, so there's some jiggling in there. That's fine. I'm just super impressed that this is actually working at all. What I should do is move the ground down so that I don't waste some space. I think I can do that. And then I stopped. That's where I stopped. It got too much thrust. But if you see here, there's that's just cool. Okay, let's fix this ground. Let's put the ground at, let's see, it starts at 700 meters high. So let's put this at the ground at minus 400. Let's call that dy. dy equals minus 400. Because now down here, I need to shift my values of everything else, right? So like up here, RA, where did I put this? There it is. So I want to actually, if I want to say plus dy, yeah. Oops. And then the same thing over here for my, this one, plus dy. All my y values are going to have that plus dy. I think that's right. And then so down here, I'm going to say plus dy, plus dy, and go. Maybe? Yeah. Who's winning now, huh? Oh, that's cool. Okay, I guess I got to add the flame. Let me do this real quick, just to show you my ultimate power. Tgraph equals graph. Xtitle equals time. Ytitle equals y. Y. And let's say F1 equals G-curve, color equals color.blue. And down here, I'm going to plot, let's plot the Y position of the rocket. So let's say F1.plot, the TI is the time, and then I'm going to say Y bottom I dot Y. No, that's it, just Y bottom I. I think that works. I zoomed out. So that's my Y position as a function of time. That's the same graph that I made before. This is the same data, right? So it should be the same graph that I got from Tracker Video. Okay, I do want to add in the thrust because why the heck not? Okay, so I can't remember how to make things invisible. So let's... I guess I could make it 0 size. Let's do that. I think I want to hold off on the thrust because I'm pretty happy with what I've done. I don't want to get bogged down in a hole. I think I'm going to call this a win. I haven't done any analysis of this, but I will post this code. You can have it and you can change it. And the thing I'm trying to emphasize here is that this is art, right? If you can model something, you can understand it. And so there you go. Now the next thing to do would be, if you want some homework, would be to calculate the acceleration of this, and from that estimate the thrust. And so kind of model it from a physics perspective, not from a data perspective. That would be fun. But let me go ahead and turn on my camera here. There you go. And to say I have had fun building this. I hope you had fun too. Tracker Video is awesome. I'll put some links down below. And if you like this, just let me know. If you don't like this, just I don't want to know because it hurts my feelings. But I will talk to you guys later.